Welcome to my channel. Last time we discussed about states of matter, the properties of matter and changes in state. Now it is not only water, nearly all the substances exist as solid, liquid and gas. One form of matter can change into another form of matter. These changes involve different processes like vaporization or boiling, condensation, melting, freezing, sublimation, etc. These are just physical changes as no chemical processes are involved in it. But remember that all pure substances have their fixed and sharp melting and boiling points. Here in the table you can check the melting and boiling points of a few substances. You can say that melting points and boiling points can help us to check the purity of a substance. It means that if the substance is pure, it will melt or boil at its specific melting or boiling point. And in case if impurities are present, then the impurities can reduce the sharpness of melting or boiling points. Impurities always decrease melting or freezing points and increase the boiling points of liquids. A graph like this is called a heating curve. It shows how the temperature changes as a block of ice is heated. First, ice melts to form water. The water gets warmer and eventually turns to steam. Here we will discuss about the heating and cooling curves, which are just the opposites of each other. In the heating curve, ice is present below 0 degrees Celsius. So we have ice present over here below 0 degrees Celsius. As the temperature starts increasing and it reaches to 0 degrees Celsius over here, which is also the freezing point, or you can say the melting point of ice, the ice starts to melt. Once ice starts melting, the temperature stays at 0 degrees Celsius until all the ice has melted. So here you can see the temperature remains constant. The temperature starts rising again until it goes to 100 degrees Celsius over here, which is the boiling point of water. So the water starts to boil and the temperature stays at 100 degrees Celsius until all the water is turned to steam. So you can see that the melting points and the boiling points both are very clear and sharp. You can reverse these changes as you can see in the second graph, which is the cooling curve. So here the changes are reversed. Over here the gas cools down and the gas loses energy. So as its particles lose energy and they move more slowly, and when they collide, they do not have enough energy to bounce back, so they get close together and form a liquid. On further cooling, the liquid turns to solid. Over here it changes into ice, and you can see that the temperature again remains constant. In all these changes you can see, like for example, in when the melting takes place at the melting point, you can see that both the solid and the liquid states, they coexist. At the boiling point you can see again the gas and the liquid, these two states of matter coexist. When condensation occurs, gas and liquid states coexist. And when freezing takes place, then solid and liquid states coexist. So far, you have seen that the temperature remains constant when the solid melts or a liquid boils, although it is heated constantly. So, where is that extra amount of energy going? Actually, what happens is that when a solid is heated, that heat energy increases the kinetic energy of the solid particles. As a result, the temperature increases. Rise in temperature is associated with the increase in the kinetic energy of the particles. So, and over here, when the solid changes into liquid with the rise in temperature, the temperature rise because the kinetic energy also increases along with it. So rise in temperature is due to the increase in the kinetic energy of the particles. Finally, the melting point is reached, which is 0 degrees Celsius. Now the temperature stops rising until all the solid melts. Here, that extra energy does not increase the kinetic energy of the particles. Instead, the particles use this energy to overcome the forces of attractions which are present between them. As a result, a change in state occurs over here. Or you can say that instead of kinetic energy, the potential energy of the particles increase. As kinetic energy is not increasing, so that there is no rise in temperature, instead the temperature remains constant. When the temperature starts rising again, so this increase in temperature is due to the increase in the kinetic energy of the particles until the liquid starts boiling again. So the temperature again becomes constant when it reaches to 100 degrees Celsius, which is the boiling point of water. So over here again, change of state the change in state happens, or you can say now the potential energy increases. There is no increase in the kinetic energy, so the temperature does not rise. It remains constant for a while until all the liquid boils and changes into gas. Once the water has boiled, the temperature starts rising again. And again, this rise in temperature is due to the increase in kinetic energy of the particles. I hope you have understood today's topic well. So thank you for watching. Please subscribe, like, share and comment.